Last episode, we made Postgres refuse to return another tenant's rows, but every one of those policies ends in the same phrase, equals the current tenant, which means the entire security model now rests on one question being answered correctly on every request in every code path. Who is asking? That sounds like the easy part. It is not. That answer has to survive authentication, a connection pool, a queue, a retry, and a background job that runs at 3 in the morning with nobody logged in at all. And it gets dropped at every single one of those. This episode is about where it goes missing, and the one that surprises people, which is that your connection pool can leak tenants through a policy that is completely correct. Start with where the answer comes from, because there is exactly one safe source. The tenant must be derived from something you verified, which in practice means a claim inside the signed token you just validated, or a lookup from the authenticated user's identity. What it must never come from is anything the caller handed you. A tenant ID in a header is a tenant ID the caller chose. A tenant ID in a URL path is a suggestion. If your code reads the tenant from a request header and pushes it into that session variable, you have built an authorization system where the attacker fills in their own answer, and you have done it while looking at row-level security in the same file and feeling secure. Resolve it from the token, server side, before anything touches the database. Now, the one I want you to remember. Your application does not open a database connection per request, it borrows one from a pool. That connection is a long-lived thing that gets handed around. So when you set the tenant on the session with a plain set, that setting stays on the connection after your request finishes. The connection goes back to the pool. The next request borrows it. And if anything on that path fails to set the tenant, maybe a code path you forgot, maybe an early return, the session is still carrying the previous request's tenant. Now your perfectly correct policy is filtering perfectly for the wrong customer. This is the nastiest version of the bug, because the policy is right, the test suite is green, and it only happens under concurrency, which is to say only in production. Requests are the easy case though, because there is a user attached. The places context actually dies are the ones with no user at all. A job goes onto a queue and comes back out 20 minutes later with no session and nobody logged in, so whoever wrote the worker had to invent a tenant from somewhere, and the usual invention is running as an admin role that bypasses row-level security entirely. Scheduled jobs that sweep every tenant have the same shape, so does anything async, anything retried, anything that fans out. The rule that survives contact is this: the tenant is part of the job's payload, not something the worker infers, and the worker runs as the same restricted role your API uses. If a job needs to touch every tenant, it loops and sets the context per tenant. It does not become a super user for convenience. One design decision ties it together. What should happen when the tenant is not set? The tempting answer is that the query runs unfiltered, which is what you get by accident if current setting returns empty and your policy compares against nothing. The correct answer is that it fails, loudly, immediately on the first query. Make the missing case an error rather than a wide-open read, so a code path that forgot to set the context breaks in the developer's face in the first 10 seconds rather than quietly returning everyone's data in production 6 months later. That is the whole discipline of this episode. Every place the answer could go missing should be a crash, never a default. In tenancy, failing open is not a fallback. It is the breach. So the database enforces isolation, and it always knows who is asking, which means we are finally safe and can move on to the other thing that shared infrastructure does to you. Next episode, one customer runs one bad report and every other customer's application stops responding. The noisy neighbor, see you there,